Hello, and welcome to today's daily Leetcode challenge. We'll be reading the description, solving the question, and then finally comparing to other solutions in the database. Today's question is 2616. Minimize the maximum difference of pairs. Minimize the maximum difference of pairs. You're given a zero-indexed integer array nums and an integer p. Find p pairs of indices of nums such that the maximum difference amongst all the pairs is minimized. Also, ensure no index appears more than once amongst the p pairs. Okay, so just to rephrase in my own words, we're given an array and an integer. The array is numbers, and p is an integer representing the number of pairs we have to find in that number. So if p is 2, then we have to pick out 4 numbers. And also, since no index can appear more than once amongst the p pairs, that means that we have to pick out 4 unique numbers if we have 2 pairs. Note that for pair of elements at index I and j, the difference of the pair is the absolute value. This is denoted by the absolute value, these things. So where x represents the absolute value of x, return the minimum maximum difference amongst all p pairs we defined. The maximum array of an empty set is set to be 0. Okay, so we're given some more additional information. We're said that the difference is the absolute value of the difference, so it doesn't matter if there's just never going to be negative numbers, and some additional information such as if p is, we define the maximum of an empty set to be 0. Okay, so if nums or p are equal to 0, that basically means then we return 0. Okay, so that's a lot to handle, but let's look at some examples to maybe get a better understanding. So we have an array of 10, 1, 2, 7, 1, 3, and p is equal to 2. So we have to pick out 4 different numbers, and the output is 1. That means that the maximum maximum difference amongst the 2 pairs is going to be 1. And the explanation is we first pick out the 1 and the 1 at indices 1 and 4. The difference of that is 0. And finally, we pick out, I'm guessing 2 and 3 at index 2 and 5. Yep. So these 4 numbers are going to be picked as pairs. 1 is going to be paired with 1, 2 is going to be paired with 3. The minimum maximum difference of those 2 pairs is 1. And that's explained here. Okay, so example number 2, and the pair is 1, and the explanation is, and the output is 0, meaning that they probably picked out these 2 2's. And the explanation is, the absolute value of 2 minus 2 is 0. Okay, let's look at some constraints. Constraints indicate that the array can be pretty large, and the values in those arrays could be pretty large. Okay, so one thing that, I don't know how to put these into words, but it seems like we're dealing with differences, right? So the first step that I would assume to be correct is you have to sort the array, right? Because if you sort the array, you're guaranteed any number within that array to have the minimum difference to the left or to the right of itself, because it's sorted, meaning that let's look at this example right here. If this is the input array, the sorted version of that would have been 1, 1, 2, 1, 1, 2, 3, 7, 10. It's sorted, and I can 100% say that any one of these numbers, any index in this number besides the left and the right, their minimum difference pair is going to be either to the left or to the right. So it's a pretty straight giveaway that the first step that we have to do is sort. Luckily, we don't have to write our own sort. We can just use Python's. But once we have a sort, what do we? I wonder if the best approach that we can do. Well, let's go back a bit. Let's say that I have this array as the input. Is there a way that I can find? Is there a way that I can find? Like I'm wondering what should be my approach to finding even a single pair, right? Let's start off with what is the min max of p when p equals 1. When p equals 1, it's pretty easy. I would just go through the array. Once, right? And in on I'll have my answer. I can see that the difference between the first is going to be 1, the difference 0, the difference between the second and third is going to be 1. That's going to be 1, that's going to be 4, and that's going to be 3. And it's pretty obvious to me, if I put it this way, that the answer here is 0. But what is the difficulty when p is greater than... Well, what's the difficulty when p is greater than 1? Well, if p is greater than 1, then if I was to use this array or these two pairs, I will miss out on this next pair because we are only allowed to use that number once. And so I'm wondering if there's some local minimums that you can get stuck in and therefore not find the optimal solution. And what would be an example of me trying to find a pair of 2 where the... Yeah, let's to prove that I have a point here, let's try to find an instance where that would be wrong. A sorted array, but picking out one of the first pairs that we see is actually wrong. So would this work? 1, 1, 1, 2, 2. It seems here that if I was to pick out the first pair, I would... Well, no, if I pick out the first pair, I'm fine. 0, 0, 1, 0. So if I pick out the first pair, yes, I miss out on the next... Okay, so... Okay, no, this does not work because I can just pick out the first 2 1s and then the last 2 2s. Yeah, it seems like there's no way that I can get into a local minimum, and if I can't get into a local minimum, then why can't I just traverse the array and figure out if a minimum difference that I'm looking at, if a minimum difference that I'm considering is valid or not. Because here's what I'm thinking at this point. If we have this as the input instead of unsorted one, we could do a search, a binary search, but a binary search not we could find the optimal min-max difference by doing a binary search over the possible answers in this question. Here's what I'm proposing. Let's get to the implementation. I first am going to sort nums, and assorted nums, let me keep this close by. Assorted nums assures to me that in the array, the differences amongst numbers next to each other are going to be minimized. Since that's out of the way, we can now do an iterative search for the min-max diff, considering that there has to be p pairs. But the search is going to be a binary search. That means that we're going to start with a low and a high, with a 0 and what is the maximum difference or number that's there? The max number is going to be 10 to the power of 9. So while low is less than high, we are saying we're going to define valid, a function called valid that's going to look at a potential difference and consider that difference if it's true or if it's valid or not. So valid is going to return true or false. Mid is going to be defined by low plus high divided by 2. And valid is going to tell us if valid, then if this is a valid solution, and we're doing a binary search over the solution. If this is a valid solution, then say that high is actually going to be equal to the mid. Else, if this is not a valid solution, then we're going to say that low is equal to mid plus 1. We're gonna try to converge on this high right here. Return high. Okay, now that we have a binary search over the potential solutions, which we know is going to be either from 0 to 10 to the power of 9, let's see what the possible what the implementation is for valid. Now valid is a, what do we do in valid? In valid, we do what we were thinking here. What I was explaining in simple words here, that we iterate over the array and we try to see what is the minimum, what is the, no, not the minimum, what is the minimum what number of pairs, or can I find p pairs in this array? If so, yes, exactly. Can I find p pairs in this array with a difference, with a min-max difference lower than diff? So in given array, can I find p pairs with a min max diff less than argument. Min max diff less than argument. Okay. Let's have this be sorted before. Actually, it's not gonna might matter. It's not gonna matter. Valid is gonna be getting called after nums is sorted. So, okay. So what do we do here? So we need to iterate over the whole array and compare all possible pairs. So I is going to be equal to 0, while I is going to be equal to 1. Len of nums. What do we do here? Okay, we also need a count. Count is going to be 0 initially, and we're going to see if we can find if count can reach at least p or more, given that the difference is going to be less. So if nums I minus nums I minus 1 is less than or equal to diff, I'm going to say count plus equals 1 and I plus equals 2. What am I doing here? The difference, the answer that we're considering right now is diff. That means that we are looking at a min-max difference that is at most diff. So if we're going to consider a pair in the sorted array, it has to be smaller or equal to diff. And that's exactly what I'm doing here. If I stumble upon a pair that matches this condition, then I add 1 to the number of count to see that I have found a pair that matches this overall min-max diff condition. And if so, then I skip my index 2. So I'm initially looking at 1, I would skip it to 2 because I can no longer use this in any pair. And else I don't increment count, and I simply increment the next integer that I'm going to be looking at. And finally, if count is greater or equal to, we can just do this. P, return true, return false. Okay. So let's run this. And I will, awesome. Let's, let me explain quickly. Well, actually, let me submit and see if this is actually correct. Okay, but wrong answer. P equals 0. Oh, there was a condition. There was a condition like that said that if P is equal to 0, return false or true. Oh, return 0. No false or 0. It's just 0. We define an empty set of pairs as 0. All right. All right. Okay, a quick summary of what the logic is. We have as an input an array. This array's property that we're going to be considering and looking at is its differences. So the best way to minimize all possible differences between pairs of consecutive numbers is obviously to sort it. So we sort it. Now that we are concerned about differences and pairs with minimum differences, we are taking the approach of doing binary search over the possible solutions. So since we're trying to find the possible min max difference of some number of pairs, we are saying the question that I'm asking is, are there 5,000 pairs with a no sorry are there p pairs with a min max diff of 5,000? If there is no if there are no p pairs with a min max diff of 5,000, that means that my high is going to be turned to that 5,000 and my low is going to stay at 0. Next question, is 2,500 going to be a valid diff, a min-max diff between in this array? If yes, then that means that my lower bound gets adjusted to the 2,500. But why does this work? Why does this work? Well, because I'm doing binary search over the array over the whole array, it means that I'm having a O log n search over my array, which is of length, I believe, of length 10 to the power of 5. And now that I'm doing that, the next step is a greedy thing that I'm doing. It's a greedy algorithm. What I'm doing here is iteratively going through all possible pairs and seeing, hey, does this pair match my difference that I'm asking? If this pair is the difference, if this pair is smaller than the difference, actually an answer that I'm searching over, then consider that pair valid and increment something called count. This count, at the end of the day, if it is less than p, then we know that this difference is not possible, right? And we have to potentially increase the difference, which will be done in the search, in the binary search. Okay, so now that I think it makes at least a little bit of sense, let's see what other possible solutions there are, and if those solutions take a similar approach. And let's see. Okay, in this solution, it seems like they definitely had the same idea of initially sorting. This is just there to get rid of that one scene. But then what is this? This array is a sorted instance of all different occurrences of all different differences in a sorted array. So this would be, okay, well, let's look at the explanation. In this case, it would be 0, 1, 3, 4, and 0, 1, 3, 4. I can now do bisect left. So bisect left, what bisect left does is given an array and some value, it will tell you where to look, where to insert that value so the array is still sorted. And I'm wondering, R is just the length of, R is just the sorted instance of all differences. So how come bisect left? How come bisect left gives us the min-max diff? The min-max diff. Well, one thing that could be happening is this value could have a number associated with, which would indicate pairs, or the number of pairs for that difference, or the min-max. And I'm assuming that that's actually what's happening here. Array of bisect left with the key being, okay, so what is this? Count and index 0, 1, while index is less than n. And just being the length of the, while index is less than n. If this matches the difference, then count. So this is the same pretty much function that we had defined. Ours was called valid, but what it's doing here is simply counting the number of, it's counting the number of pairs possible, the number of pairs possible with a specific difference, max difference. So in the case of, well, nums, in the case of this, a sorted version of this, and a max being returned of initially oh, well, this is going to be 2, right? P2. So with a max of P2, where would I insert this count 2? 0, 1, 2. Okay, I'm really confused. Let's look at if there's a, yeah, I'm really confused. Okay, I think I abandoned the idea of looking at what that means, of what the best solution is. Maybe because I don't entirely understand what bisect is. Maybe I'm just under stress. But I think this is a valid solution, and I think that beating what 75% of the 78% of all the other solutions is good. So yep, please use this if you want, and I will see you tomorrow. Bye.